Okay, the last of our exponent rules is really actually the easiest when it pops up into a problem. It kind of makes the entire problem simpler. Basically, it's looking at what happens when you raise something to a 0 power. So let's set up an example of something that would simplify to a 0 power. So we'll go back to x to the 5th. Say I have x to the 5th over x to the 5th. Well, just from looking at it, I know that anything over itself, like 7 over 7, equals 1. So x to the 5th over x to the 5th must equal 1. What if I did this instead by subtracting exponents? I would get 5 minus 5, x is 0. I don't know what x is. X could be anything. What this means is that anything raised to a 0 power, just equals 1. As I said, this makes problems easier. Say I have something like 3x to the 4, y to the 8, whole thing to 0, over 2x to the negative 5. Well, right away I could say, okay, I need to get rid of that parentheses, and that entire parentheses is raised to 0 power. So that entire numerator is now 1, over 2x to the negative 5. As we said before, we don't want negative exponents in our answers, so I'm going to take that negative exponent, that negative 5, and flip that to the top. My 2 had a positive exponent, so that's going to say where it is. So that's my final answer. Set up another one that could be, I guess, a little bit more difficult. 3 x to negative 4 y squared over 6 x to negative 2 y to negative 7. Make the denominator to the 0, the numerator, make it to negative 2. Okay, so again, first thing I want to do is get stuff out of parentheses. So let's see, I have 3x to negative 4, y squared, that being raised to negative 2, so I'm going to take that negative 2 and distribute it to all my exponents. So going to my first exponent, it's going to be 3 to negative 2. Then x to the 8, y to negative 4. Okay, and my denominator, oh, it's raised to 0 power. That means that entire parentheses is just 1. Okay, that was easier. Don't want negative exponents, so let's see, 3 has a negative exponent. I'll flip it to the bottom and make it 3 squared. X has a positive exponent of x to the 8. Y has a negative exponent, so I'll flip it to the bottom and make it y to the 4. For my final answer, I probably want to simplify it a little bit more. So 3 squared is 9, y to the 4. My x to the 8 is by itself in the numerator. Okay, let's set up, I guess, a pretty hard one. If we can get through this, then you should be able to get through almost anything. How about 3x to the 4, y to negative 6, that squared, over 6x to negative 2, y to the 8, that to the negative 1. Let's multiply some stuff in here. So let's put a 4x and negative 3 on the top. We'll raise that to, what about a negative 2 power? Sounds good. And hell, we'll just raise the whole thing to, how about negative 1 at the very end? Yeah, this looks relatively evil. So let's start out. I'm going to start off again by getting stuff out of parentheses. So I'm going to work inside my big parentheses. So inside this big parentheses here. And I'm going to start by just getting my 3x to 4, y to negative 6 out of parentheses. So I'm going to take that 2 and distribute it. So I will get 3 squared x to the 8, y to the negative 12. Okay, let's get my 4x to negative 3 out of parentheses, so I'll distribute that negative 2. So 4 to negative 2, x to 6. Now I'm going to get that 6x to negative 2, y to the 8 out of parentheses. So I'll distribute that negative 1. Remembering to put a 1 next to all my numbers. So 6 to negative 1, x to the positive 2, y to the negative 8. Now this whole thing is still to negative 1 power. I can distribute that negative 1 power right now if I want to get everything out of parentheses. So might as well. Heck, all it's going to do is change all the signs of every exponent. So just make sure it distributes to every exponent. So let's see, I'll get 3 to negative 2, x to the negative 8, y to the 12, 4 squared, x to the negative 6, over 6 to the positive 1, x to the negative 2, y to the 8. Okay, so I'm out of all parentheses, and we didn't have to do that right then. We really could have simplified inside the parentheses a bit, but it's not really going to change much either way. Okay, so I'm going to flip all my negatives. In my numerator, my 3 is going to flip to the denominator, become 3 squared. My x is going to flip to the denominator, x to the 8. My y to the 12 is going to stay where it is. My 4 squared is going to stay where it is. X to 6 is going to flip to the denominator. And my denominator, 6 is going to stay where it is. X squared is going to flip to the top. And y to the 8 is going to stay where it is. Okay, now I'm going to simplify, and usually I can simplify all in one turn, but this has a lot more stuff in it, so I'll probably take a few. In my numerator, only thing I can simplify right now is that 4 squares, so I'll get 16. Keep everything else the same. I like to write my x's first and my y's second, so I'm going to do that. Okay, my denominator, I have 3 squared, which is 9, times 6 should give me 54. X to 14. Y to the 8. Last thing I need to do is divide, so let's go ahead and divide this. 16 over 54, I know 2 goes into both because they're both even. So 8 over 27. X squared over x to 14, I'm dividing. Got the largest exponent in the denominator, so I'm going to get x to 12 down there. Y to 12 over y to the 8, largest exponents in the numerator, so I'll get y to the 4 up there. Check it and make sure there's nothing else you can simplify. 8 over 27? No. Single y, single x. I am done.